Okay, so listen. As of recently, and by recently I mean for like several months now, I was thinking about speed and how it is applied to fiction. This all started because I was writing an action-adventure novel and was wondering how I could create characters that have superhuman speed but cannot like run around the entire planet several times within just a few minutes. In my attempts to solve this problem, one of the things I did was turn to Powerscaling and analyze the way it divides and categorizes the idea of speed and use that to influence the way I could apply it to my stories. However, when I did this, it just led me to various other problems that Powerscalers have yet to find a reasonable solution for that don't, by virtue, arrive at paradoxical ends. Because of the aforementioned, I'm here making this video with the goal of not only explaining, but also giving solutions to the underlying problems I have with how the idea of speed is treated and applied to fiction. The way I plan on doing so is by first explaining the concept of speed in excruciating detail. Following this, I will list and explain the ways the idea of speed is categorized in fiction. After that, I will explain in detail the various paradoxes that can arise with the differentiation of speed in fiction before moving on to create and present various so-called speed models which will attempt to solve the multitude of paradoxes. As a side note, I should clarify that when I say that Powerscalers have yet to address or give a solution to the problem or problems I'm about to lay out, I'm mainly referring to the fact that it isn't common knowledge within Powerscaling, and to my knowledge, massive Powerscaling presences such as large YouTubers or Versus Battle Wiki have yet to address or speak on it in a manner that leads to widespread awareness. It is virtually impossible for me to prove the assertion that no one has ever talked about it or solved the problem I'm about to explain. I can only speak on things to the extent of my knowledge, which is what my beliefs have a basis in. However, I'm fairly confident that stating what I'm about to lay out isn't well known is an agreeable affirmation. Now, with all of that being said, allow me to begin the exposition of my argument. As stated previously, I'll start things off by explaining the concept of speed. Speed is a derived concept that lies on the ideas of space and time. Space is measured in dimensions, but with speed we only need to worry about the first dimension, which is length or distance. It describes the physical distance that exists between objects. When two objects exist, we tend to be able to observe their degree of spatial proximity and determine when a set of objects are closer or further apart when compared to other sets. We have mathematically created units to measure the idea we call distance. These units are things like meters, feet, inches, yards, etc. Time is simpler, as it is a concept that describes the observable physical change of an object. To exemplify what I mean, let's compare an image to a video. An image depicts objects with no physical change, as no matter how long you look at it, its contents will not change. You can say its contents are stationary or invariable. Juxtapose this with the objects within a video. A video can be defined as a sequence of images whose object is causally connected to the image which precedes it in order to display the change of the object. That observable change is defined as time. Put simply, time is continuous or variable rather than still or invariable. Using this knowledge, we can define speed as the degree to which an object traverses a specific distance in a given period of time, or the magnitude of an object's positional change per unit of time. I gave that detailed explanation of space or distance and time because, in real life, special relativity tells us that there is a cosmological speed limit alongside the fact that time is relative and slows down as you approach this speed limit. This means that traveling faster means you're perceiving time slower. However, this isn't noticeable until you reach speeds that equate to fractions of the cosmological speed limit, which is also known as the speed of light. In fiction, we tend to ignore or bend the influence of this speed limit since there are many occasions where its application doesn't correlate with what we see or what we can observe within the fictitious setting. Given the way the speed of light is defined, it is also something that can be modified by affecting other variables, so its application isn't necessarily absolute when compared to other things. Keep all of this in mind as I move on. With the definition of speed out of the way, I'll move on to explaining the ways speed is generally categorized. Generally, the Powerscaling community categorizes speed into 6 different types. These types are travel speed, combat speed, attack speed, movement speed, reaction speed, and perception speed. Travel speed is defined as the speed at which a person can travel. It is basically what people generally consider speed to be. An example would be like a person running. Some people differentiate it from flight speed, which is defined as the speed at which one can travel via flight, while they define travel speed as purely terrestrial, but possibly aquatic movement. I personally don't see the need to do this since the functionality difference is infinitesimal when compared to the other classifications. Strictly speaking, combat speed is defined as the speed at which a character can fight, which includes the speed of their punches, their kicks, their reaction time, their perception time, etc. It differentiates itself from travel speed in the same way Mike Tyson differentiates from Usain Bolt when it comes to speed. The reason I say strictly speaking is because there are many people who would extend the definition to more than just the aforementioned. They will classify total short distance relocation via running, flying, jumping, leaping, etc. as combat speed, which I see as fallacious, as I'll detail later on. Attack speed is defined as the speed at which one's attack travels. It is differentiated from travel speed and combat speed because the attack in question exists independently of the user. The easiest way to exemplify it would be a person shooting a gun. The bullet would be one's attack speed, while the speed at which one can run and punch would be their travel and combat speed respectively. Movement speed is the speed at which one's body can travel. It is closely related to combat speed, but different because one can have high movement speed with low perception speed, which would result in low reaction speed, which would result in terrible combat speed, as combat speed requires you to have a balanced level of movement speed and perception speed. Reaction speed is defined as the speed at which an individual can react to things. It is closely related to combat speed, but it differs in that reaction speed just involves quick, one-time movements that can be voluntary or involuntary. The user can perceive things and react to them at this speed, but they cannot usually punch, kick, or travel at this speed. Reaction speed can also be seen as reflexes, and it is heavily dependent on perception speed and movement speed. The final speed classification I'll talk about is perception speed, which is sometimes combined with reaction speed, but I like to differentiate them. It is defined as the speed at which one can perceive things. It is generally used to refer to visual perception, but can also apply to audible perception or any kind of perception that involves the brain processing and understanding information via observation. It is differentiated from reaction speed because while the user can perceive things at this speed, their bodies cannot move at this speed to defend against the things they're perceiving. When they can, it is referred to as reaction speed due to their high movement speed. The main problem with the speed classifications is that they do not solve three problems I have. I refer to these problems as the transportation paradox, the immortality paradox, and the force paradox. The easiest way to explain the transportation paradox would be via exemplification. Let's say a character is able to react to an attack that is stated to be moving at Mach 100. In reacting to this attack, the character moved 10 meters in the same time frame it took the attack to move 20 meters. This shows that the speed possessed by the character is comparable to that of the attack. Later on, this character needs to take transportation to travel a distance of 5,000 kilometers and considers that distance to be very far away, with the journey taking days. In this scenario, why doesn't the character just begin running or flying? If they do so, they'll arrive in less than 5 minutes. If they can travel 10 meters in mere milliseconds, then they can travel over 1,000 kilometers in a minute. This is basic inference, so why aren't they doing so? You can change the units of speed, distance, and time that I used. The point is that there are occasions where characters are scaled to be immensely fast, but they consider distances that should take them little time to travel to be immense or untraversable. This is in contradiction with their speed scaling. This is why I said I have a problem with extending the definition of combat speed to moving short distances, because at that point it is no longer combat speed, if not it becomes travel speed. Many people will attempt to solve this problem by proposing that, due to relativistic-like effects, characters that move very fast perceive the world around them slower than those who move slowly. In somewhat basic terms, it is modified time dilation and is depicted with characters such as the Flash. This means that they perceive themselves the same way we perceive other humans in terms of speed, but they perceive the world around them as moving in slow motion, if they're sufficiently fast of course. This means that a mere second in real time is like minutes to them. This all culminates into the fact that if they were to travel this large distance at full speed, it would be no different than if they were to catch a plane, because when they move at these high speeds, they don't feel themselves moving faster. If not, the world around them slows down. It's like time manipulation, where to the user, they remain unchanged while everyone else just slows down. However, from everyone else's perception, they have remained unchanged while the user is moving extremely fast. This now means that it may just be a few minutes in the real world, but to the user, it would have been hours or days of running or flying at full speed, and they do not have the stamina to remain continuously active for such a long period of time. While this explanation may seem favorable at first, it is actually the basis for the immortality paradox. You see, the problem with this rationale is that many times in fiction, it is the case that a specific time frame is stated in the real world, and or effects such as gravity and destruction take place while the characters are fighting. This implies that many seconds, if not minutes, are passing in the real world. If you scale this back to very fast characters, it would translate to hours passing from their perspective, which tends to not be realistic since it implies it took them hours to follow up punching a character after one punch destroyed a building and we see the rubble. Extending this to massively faster than light characters such as Goku, it could imply that they were fighting for decades on end while mere seconds passed in the real world, which is not realistic as many series treat real world time to equate or be relative to the supposed perceptual time. This explanation leads to characters requiring virtually infinite stamina and being immortal if they battle for mere minutes in the real world at FTL speeds. Allow me to exemplify what I mean. Most humans cannot visually perceive things moving at speeds that exceed 77 meters per second if they're very close to it. If you say a character is FTL, it puts their perception speed millions of times above that of a regular human. This means that 1 second to a human would correlate to millions of seconds or over 45 days for an FTL character. This results in mere minutes being almost 7.5 years to them. Extending this to massively faster than light characters, a single second to a regular human is over a century to them. This is why they need to be immortal and have infinite stamina for the rationale that they perceive time slower to work. The reason the time difference would be directly proportional to the speed difference is that the explanation is supposing that as speed increases, the only noticeable change is the world slowing down. So if the world slows down 100-fold, you'll be moving 100 times faster and vice versa, as speed is inversely proportional to time when distance is constant. If you want to say that it isn't inversely proportional, if not time slows down by something like 1/100th of the degree at which speed increases, then this results in the fact that the explanation can counter itself. The reason I say this is because if the degree to which time slows down relative to speed is very low, then you cannot use time as the reason why they can't move these large distances, as it would be oxymoronic. You can't say that it is inherent that a character perceives time extremely slow compared to everyone else, but perceives it fast enough relative to everyone else that it isn't problematic. If the character is sufficiently fast, this reasoning is self-contradictory. Adding to this, if it isn't inversely proportional, it would also make it so that slowing down time isn't the only noticeable change for the character with immense speed. They will also feel themselves becoming faster. For example, if they can move at 100 kilometers a second or over Mach 291, but time is slowed down by a factor of 1/100th of the speed increase, then it will just mean that 1 second in the real world is equivalent to 100 seconds to them. Meaning that, relative to themselves, they can move at 1 kilometer a second rather than perceiving themselves as regular humans while everyone else is just extremely slow. This would mean that within a mere minute, they can travel several dozen kilometers, which would result in this supposed solution to the transportation paradox not working. When it does work, it can result in the immortality paradox, and trying to solve the immortality paradox can create the transportation paradox. When neither of the aforementioned paradoxes apply, the argument can contradict the narrative when it comes to explicit or implicit time frames as explained previously. The other paradox is the force paradox, which goes like this. How can a character move at immense speeds, like let's say FTL speeds, yet they aren't harming the environment around them? Like when they jump or dash or punch, the kinetic energy of their attacks isn't on display. The opposite is true as well. Why when sufficiently strong characters punch or kick or jump, their strength isn't strong enough to accelerate them to immense speeds? These instances would seem to suggest that the force formula, which is F equals ma or force equals mass times acceleration, is violated. This would result in the violation of formulas such as the kinetic energy formula, which would mean that within that series, kinetic energy and other formulas relying on this definition of force would be unusable. Now I'll start giving some solutions for the aforementioned problem. For the transportation paradox, I don't have a specific solution. In the case where a character can shift their entire body by several meters in order to avoid a very fast attack, but treat many kilometers as being very far away and requiring transportation to arrive at this location, is fundamentally paradoxical unless there are external variables that change it. The feat that is detailed in this paradox is often classified as combat speed. However, I believe that this should rather be defined as travel speed and be ruled a contradiction and be discarded. I believe that we should strictly define combat speed as unipositional movements, which includes stuff like punches, kicks, moving one's head, ducking, reacting, etc. Basically, one cannot move one's entire body at this speed, such as running, leaping, flying, etc. But one's limbs can move at these speeds and one can perceive and react to things at these speeds. To visualize it, imagine a character who can punch faster than a bullet, catch bullets, and dodge bullets, but they run slower than Usain Bolt and cannot shift the position of their entire bodies by several meters at the aforementioned speeds. For the immortality paradox, I propose the objective time theory. It goes like this. Rather than time or physical change being relative to the speed of the observer as it is here in real life, it is a generally objective metric where 1 second for someone moving at FTL speeds at the other side of the planet is the same as it is for a regular person on Earth. It is similar to how a video has objective time, as it is a series of changing stills that play at 1 second per second. However, here's the catch. The brain of individuals work on a principle that is somewhat similar to flops, where to perceive and react to a very fast object, your brain must be able to process a higher degree of operations per second than a normal person. For example, let's say the average person has a perception speed that can numerically be represented as 100. To react to a bullet, you must have a perception speed of 1000. This means that someone with a perception speed of 200 would get blitzed by a bullet. However, someone with a perception speed of 2000 will be able to see and react to a bullet traveling. The event is happening at the same time for all observers as time is objective. However, the speed at which they can react to things depends on the amount of information they can perceive in a given time frame. This also applies to combat speed, since your body must have a certain level of both movement and perception speed to intercept attacks. With this theory, you can still perceive things as slow and fast, as it would depend on the amount of operations your brain can perform in a given time frame relative to that of the object you're looking at. If the rate at which you perceive information is higher than that of the object, then you perceive said object as slow. If it's slower, then you perceive said object as fast. The degree to which it is slow or fast also depends on the degree to which your operational speed is relative to it. If it's 100 times faster, then you'd perceive the object as moving in slow motion, while if it's 100 times slower, you wouldn't be able to perceive it at all. I shouldn't say you'd perceive it in quote-unquote slow motion. It's more like you can comprehend it and formulate a response to it instantaneously. You can run countless operations within the given time frame you have. More operations than someone with a lower operational speed than you. For the force paradox, one of the ways to rationalize it is by saying that the formulas do not change. If not, the theories governing these formulas have an unknown externality that modifies the law to the extent that there are differences between its existence in fiction and its existence in real life. However, due to the nature of this externality, the formulas remain the same, but just the effect being different in a few ways. Like this, the apparent contradiction can exist, with the formulas also remaining the same. I believe this to make sense, as there are many ways in which the theories are similar to the way they work in fiction. However, some liberties are taken in their modification, as is with many reality-limiting concepts in fiction. The other way to look at it would be to just say that the theories are self-evidently contradicted, thus they cannot be used. And even though the effects in fiction are similar to those in the real world, they are dissimilar enough so that the formulas in fiction are unknown. This ultimately delves into questions such as, should physical principles in fiction be modified or discarded, to what degree they should be modified, and when is it acceptable to modify them or discard them due to contradictions. I have talked about this in the past and will continue to talk about it in the future as well, but to summarize, I believe they should generally be modified to an extent. And this is one of those instances in which the modification is acceptable. And yeah, that's about it. Bye.